will be recorded, and I'll post the recordings afterwards. So if you want to ask live questions, you have to attend lecture. Otherwise, you can view the material asynchronously online. Welcome. Yeah, COP-3402. If you're in the wrong place, I suggest you go to a different room. Yeah. So I'm going to make you a promise before we begin. If you do not know the Linux command line, if you do not know bash, if you do not know git, if you do not know make, if you do not know what compilers are, or how to use compilers, or how to write your own compiler, then by the end of this course, you will know more than you do now. You will know a lot more. And you'll actually learn skills that will make you a stronger engineer, practical skills, unlike what I think a lot of courses at UCF teaches, that you can directly use in your future careers as software engineers. So without further ado, I think we can begin. So some background on me, as you probably can all see, I'm a lot younger than a lot of professors you'll see here at UCF. That's because I'm not a professor. I'm a GTA, graduate teaching associate, so I'm a PhD student under Dr. Paul Gazzillo. He's my advisor, academic advisor. He originally taught this course. When I first took this course, it was 7 years ago, actually. I think it was 7 years ago with him. And the course was a lot different then, and I really enjoyed it. I liked it so much that I wanted to have him as my advisor for a PhD, and I reached out to him last semester if I could teach this course, because I really enjoy teaching, and he said sure. I was a TA for the course all last year, and it went so well. He had the highest student perception of instruction ratings that he'd ever received, so he said sure, I can teach the course. And another reason why I'm doing this is because my career after graduating is to be a professor at a teaching-oriented university, and this is a great opportunity to practice that. So yeah, my research is in these 3 areas, sort of the intersection of these 3 areas. If you want to know more, you can click on this link here or go to the webpage. It's my website, all about me. One, I guess, personal thing I'll share is that I really like to read. I read a lot of literature and whatnot, so if you like to read, if you want book recommendations, you can check that out. Come and see me afterwards and we can talk about books. So I kind of want to get a poll about all of you. Raise your hand if you're a CS student. Okay, I figured. Anybody not CS? Yeah? If you don't mind me calling you out, why are you taking this course?
I mean, I am a CS student.
Oh. Oh, okay, cool. So everyone's at least CS. Yeah. Again, this course was all originally authored by my advisor, Dr. Gazzillo, so if you don't like it, blame him. No, I'm just kidding. Blame me. So I want to begin by asking the question, why should you study system software? And I want to begin with this sort of historical anecdote. I'm sure you all know Isaac Newton. Yeah? Can somebody tell me what he's known for, or one of the things that he's known for? I'm not sure if that was Newton. Yeah, gravity, similar, not Newton. Yeah? Calculus, yeah. So he invented calculus, I think at the same time as Leibniz, maybe, I'm not sure. Gravity as well, sort of like invented calculus to explain gravity. And one thing Newton did, he didn't just do research, he also invented his own tools. He was an engineer. So this photograph here is from Newton's own journal. He did astronomical research as well, and he would grind his own lenses, make his own lenses for doing astronomy, because you couldn't just go and buy them at the time he was alive. You had to make them yourself. And that's kind of one of the tenets of what we're going to be doing in this course is, in order to study system software, we're going to be inventing our own system software tools, learning how to use those tools and learning how to make our own. And there's a saying here, a poor workman blames his tools. This is doubly so in our field because we can make our own tools. Especially when you're working with software, you can move fast and break things. That's like Facebook's famous quote from years ago, their motto. We can modify any tools that we have, and if you don't like them, you can just modify them as well. A lot of software is open source these days, a lot of the software that we use, especially in this course. And my advisor has this quote that he thought was from him, tools are made for man, not man for tools. So again, don't be locked into whatever tool you're using. If a tool isn't working, but you have an idea of how to solve a problem, don't think the problem is insurmountable, just try and fix the tool. And this quote is actually not from him, it's from others as well. Aldous Huxley, Thomas Merton, Technology is made for man, not man for technology, so similar. And again, this is not my dad, from Dr. Gazilla's dad. Don't use your bare hands, use a tool. I feel like a lot of people's relatives, older relatives, have probably told them something like this at one point or another. Use the tool fit for the job. And we're going to be encountering a lot of different tools throughout this course. And that brings me to the goals. So number 1 is to learn to use system software. Number 2 is to create it. So first of all, I guess we should lay down some definitions of what exactly is system software. There's a lot of definitions in textbooks that are, and in Wikipedia, that are kind of vague, not very concrete. So we're going to go with this definition for this course: the bridge between the kernel and applications. So you can think of a hardware software stack here, where the bottom level is the hardware, that's like closest to the machine, it literally is the machine. And the top level are the applications that you as a user use. So these are things like web browsers, video editors, the internet, streaming services, etc. And the kernel sits on top of the hardware. That comes installed by default on most machines you buy. And system software is kind of in between applications and the kernel. It's tools that you don't use directly as a user of software, but the developers write so they can write their applications to interact with the kernel. So we're going to be going over lots of examples of those throughout this course. So some examples, right now just some examples, are std.io. If you've programmed in C before, you are familiar with the standard library. malloc, so memory allocation. Tool chains like compilers, so GCC, CLang, the Intel compiler. There's a few C compilers out there. Linkers, the one you probably all use is LD. You probably never use it directly. You just use it through GCC indirectly. Programming environments. So who has used Git? Could you raise your hand if you've used Git? Okay, that's good. Who has used Make? Okay, a lot fewer people. That's normal. We're going to be going over versioning, so Git and build systems, Make specifically, in the beginning of the semester. So we'll get onto that later. So the first goal here is, to use system software. So I'm going to show you in this course how to be much stronger on the command line, how to move swiftly on the command line, and how to perform a lot of different actions through using only the command line, not using a GUI or File Explorer or anything like that. And if you don't believe the command line is powerful, let me see, what's the next thing here? So I have some examples I want to share. You can explore a file browser on the command line. So this is an example of one. You can actually view images on the command line if you have the correct tools installed. You can go to web pages on the command line. So this is small, make it a little bit bigger. So I go to my web page that I showed earlier. You can see it all loads. This is all just on the command line, not in the browser. And last one, who likes coffee? Yeah, okay. Does anybody watch the YouTube channel, The Primogen? Yeah, a few people? Okay, good. Some people know what I'm talking about. This guy's a big programmer. He made a coffee shop that you can go to online through a web browser, but you can't buy coffee on the web browser. To buy the coffee, you have to actually SSH into a remote server. So you can see right here, this is the whole shop. And the coffee have funny names. So the decaf coffee is called 404, caffeine not found. Not going to advertise, but just trying to give you a taste of some of the cool things you can do in the command line if you just know what tools are out there. And if you have, creativity, imagination. And we're going to be going over Git, so version control. Software engineers use this all the time in practice. And the file system. So raise your hand if you don't know what a file is and are okay to admit that. Okay, good. My advisor has told me that in recent semesters, a lot of students are coming in with their only experience with technology being Apple products, where they only see app icons. And because of that, they do not know what a file is. They have no idea of file hierarchies or file trees. They just know apps and icons, and then that's all they need to know, so they don't understand what files are. So I kind of wanted to see if that's true. I'm starting to think that's false. I haven't really met anybody in person who thinks that. So I think that's good. And the new Linux development tool chains. This is just using Make, really. We're not going to be going over some of the other tools that GNU and Linux provide, just really Make specifically. And of course, we're going to be building system software. So file handling software, so file abstractions, file system, reading, writing files. We're going to be writing software for the course projects to find files in your machine, to copy files potentially, to emulate a terminal, emulate a shell, and we're going to be writing all these programs in C. So I hope you all are decently familiar with C. I mean, I know CS1 is a prereq for this course, so you should all be fairly competent in C. I think the projects are fun. They're not going to be easy, I won't lie. They'll probably be challenging, but they'll be very clear in what you have to do. I think they'll be fun and challenging. So process management, creating processes, executing programs, manipulating I/O. So does anybody know what a process is? Just curious. Yeah?
Program being executed.
Yeah, exactly. So we'll be going over that more, this semester. Compilers. So this is a cool one. So everything I mentioned so far is only the first half of this course. Learning how to use and write system software. The second half of the course, we're going to be writing our own compiler for a simple programming language. Now, in previous semesters of this course, when I took it with Dr. Zillow 7 years ago, the whole course was just making a compiler. He had spent the previous winter break writing a whole compiler in C, and then he just took out all the function definitions and gave it to us piece by piece as the semester went on. And that was our course-long project, to write a whole compiler in C. But he found that a lot of students lacked the knowledge of Git, of Linux, of the command line, of make even, that they needed to know in order to actually write the compiler and test their code effectively. So that's why the first half of this course now is going to be all about learning how to use those tools. Because I can't take it for granted that any of you know that, because I didn't even know all of that when I was an undergrad. So my other motive here is to make everyone a better programmer. As you can tell, I'm very passionate about programming. And the analogy I'm going to use to explain this, or allegory I should say, is the tortoise and the hare. So does anybody not know the tortoise and the hare? Yeah, I figure everyone does. By the way, Dr. Gazillo is there calling him out. And, sorry. So the story here will be the tortoise and the hare both given a programming project. They're two animals. You already probably know how this is going to go. The hare starts coding right away. They do not waste time. They want to get to spitting out code. The tortoise does not begin immediately. They start writing comments. They start planning what the outline of the program is going to be. And they start writing tests. They start thinking of what potential inputs and outputs should be. And they record all of that in separate files for later, before they even start writing a single line of code. So before the tortoise even starts, the hare is already done. And that sounds like a good idea, but wait, there's more. Now, if you've ever written a program before, you know this is when the actual challenging part begins. So who has written a program more than like 100 lines of code long? And was that program totally correct the first time you wrote it? Was there no bugs? Yeah, most people, I don't see a single person like saying yes, there was no bugs. So this is the really challenging part, debugging and getting tests to pass. So, oops, I think I skipped ahead here. Yeah, so the hare starts to run tests, and these are the given tests, just one of the tests that they have access to from the beginning of the assignment. And of course, it breaks their program because they just rushed to finish. They weren't checking that it was correct as they went along. So they start guessing on what might be broken, and they fix it, but now another test is breaking. And if they're lucky, if they keep doing this process, this ad hoc process of fixing and going back and fixing again and whatnot, eventually all the tests will work. But then they still get a low grade because after they've submitted their project for grading, there's a bunch of hidden test cases, and that's going to be the case here. I'm only ever going to give you half the test cases this semester. The other half are going to be hidden. I'll give you the names of those hidden test cases so you can get an idea of what you can testing on your own, but I'm not going to give you the actual test cases, or the hidden ones. So meanwhile, the tortoise starts dividing up the problem into simpler pieces. So I don't know, you've all said you've taken CS1, so I think you're familiar with the divide and conquer approach to algorithms. The tortoise is practicing divide and conquer here. So they write simple examples to illustrate the problem, take an easy piece of the problem and writes comments about what the code should do, and only then, little by little, testing along the way, do they code. So again, making sure things work before moving on. They're not breaking tests by fixing current tests that are breaking. And yeah, the tortoise is aware that debugging is difficult, especially when there's lots of bugs together. So the tortoise tries to minimize the number of bugs that appear while making new changes. And when the tortoise is done, there are not really any bugs to fix, and they don't have to go back and correct any test cases. They get a good grade. So another idea here I want to sort of get across is that speed is not always raw velocity. True speed in software engineering sometimes looks slower than like smashing out keyboard shortcuts in your editor or whatever and typing out like lots of code all at once. If you know how to write code, like if you know the basics of programming languages, it's actually very easy to just churn out a ton of code that is really garbage. What's really fast is to go steadily, slow and steady like the tortoise, write code that is correct, and then not have to go back and change anything or fix anything because it's already all working. So when the tortoise submits their project for grading, of course they get a great grade, all the tests pass. And if he does have any tests that don't work, he just isolates it with one test because his code is better well divided anyway. And yeah, even unseen tests are likely to pass. So again, the idea here is to be the tortoise, write code that is safe, secure, correct. And there's real repercussions when you get into the workforce if you don't do this. So has anybody heard of FAIR Act 25? Yeah, can you explain it? Give some background and why it's known.
So it was like a radiation
Therapy.
machine, therapy machine used in a hospital, and the code was, I don't know, rushed through or just written.
It was made by one person. It wasn't very well thought out.
And there wasn't that much documentation.
No,
on
there
it
was, I think,
either.
hardly any documentation.
And so there were multiple instances where it put way more radiation into the people it was trying to help their cancer, put way more into them than it should have, and it killed many people.
Yeah, so at least 6 people were heavily injured by this radiation therapy machine. It would give them large doses of radiation by accident because it had bugs in the software. In fact, at least one person was killed because of this machine. And you can see this today with like Boeing planes. They crash because of software malfunctions. So be the tortoise, don't be the person who writes software that accidentally kills people. That's the true repercussions of writing software too fast. So here, know your tools well, like we said, like we began with. Know your tools. You shouldn't have to test the fundamentals of a language as you're writing code. It will slow you down, and it will lead to errors. You'll introduce new errors into your code because you're second guessing yourself as to how the language actually works that you're working in. So know your environment well, develop fast workflows. You can do this in any environment, really. I don't care if you use like VS Code or Emacs or Vim or whatever you choose to use. Just know it really well. I would recommend not getting into a development workflow where you're writing code, saving and quitting, compiling individual files, and then running them again. That is very slow. Find a way to map that to a hotkey or something. Like we'll go over that later in the semester. You should develop fast workflows of edit, compile, test. Edit, compile, test. You should be able to do that like this. So breaking the problem down into pieces, again, divide and conquer, like what the tortoise was doing at Aurora. Divide your code up into appropriate functions, and then go from there. It will also make your code easier to test. Yeah, this should be, hopefully, I mean, it's common sense, but people forget this. Make sure the simple stuff works before moving on. And write your own tests and save tests. Don't delete a test or keep one test file that you're constantly making changes to for a new functionality you want to test, because you might go back and want to test something earlier that you wrote. It's better just to create new files every time you have a new test. And develop good debugging skills, and we'll talk more about this later. This is a link to a page or actually later on in this presentation, so you'll see that then. And I don't know, has anybody heard of Brian Kernighan? Really? No one. I'm surprised. Oh, you have? Okay, so what is he known for? What's one thing that he's known for? So he didn't write C. Yes, he wrote the book, The C Programming Language. It's, I think, like probably a hard reading here for Intro to C Programming. It's actually a really great book. He re-implements, him and his co-author, they re-implement many Linux utilities in C and show you how to do it. So it's a great way to learn how to write code in C. And he has this sort of like funny quote here. It's not totally serious, but there's a grain of truth to it. Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? So think about it. If you use all your brain cells to write some code, you don't have enough to debug it, because debugging is going to be harder than actually writing the software. So make it simple. Make it easy to write the code so you can debug it later on. And now, speaking of bugs, I want to ask the question, what is a bug? So can somebody give me, I'll ask several people here, a definition of a bug?
An unforeseen mistake in the code
Okay,
that we wrote probably.
probably, yeah.
Something not doing what's supposed to?
Not doing what it's supposed to, okay. Can I have a third definition? Anybody else?
A flaw in the program.
A flaw in the program. Okay, so I'm going to be a little contrarian here. I'm not meaning to call you out. But I'm going to say it's not the program is doing something wrong. I'm going to say it's more like what the first two people I had asked said. It's really more of a mismatch of expectations. And you could say this is something wrong because it's not matching what you expected. So when we write code, we have an expectation of what the program should do, and if it doesn't quite match what we think it should do, that's actually what a bug truly is. I'm going to argue here. And there's a way to fix bugs, and this kind of goes with everything we've been saying so far, dividing up your work. So narrowing down your problem scope, isolating your code into individual functions, and writing specific test cases for each functionality you desire, and then you'll be able to pinpoint what the cause of each bug is. Now I'm going to actually create a new window here to show this. We're going to make the specification match the implementation. That's what we're going to be doing this semester. You can think of the assignment descriptions as a specification, and the implementation is the code you write to fill that specification, to complete that homework assignment. And there's different ways to do this, so I'm going to start drawing a diagram here. Oops, delete this. But this is the specification, this box. And this is the implementation. Our goal is to translate the specification into an implementation. Or I'll just draw a person here, so a little stick figure. So this is you translating the specification into the implementation. And there's a few different ways to do this. Bless you. The hard way that feels easy is to do what the hare was doing in the allegory and to translate everything into the implementation at once. So you take the entire problem specification and turn it all into code all at once. And I'm going to try and illustrate here why that's a problem, why that's not a great approach. Let's say we have our arrow connecting these two. So if you're translating the whole specification into implementation at once, you end up with a situation like this, where green represents parts of the program that work. See if I can get this green. There we go. We can say like most of it's green, most of it works. I wish I had a bigger pen here, but that's fine. But in the middle of all this, there are some parts that are broken. Oops. A few little bugs. I'll just put little red circles in here. And they're all over the place. And it's hard to know where they are. I guess that doesn't work. Oh well. Because you're trying to look at the entire implementation at once to find these bugs. The search space is wide. Now, I'll contrast this with a better approach, which is what the tortoise does in the allegory, is to, and this is kind of a lazy way to look at it too, because you're not doing as much work all at once, is to gradually expand what it is you're working on. So I'm going to undo these changes here, and I'm going to draw some black lines. So divide the problem up into components. That's fine. And I'll actually draw similar components in the implementation side. So one here, and one here. And now when you're translating the specification into the implementation, trying to actually write your code, you start with one component, and maybe you get that one entirely right. Move on to the next one, and maybe you have one bug. Oops, I'll make this red. Somewhere in here. There we go. And you might still have a bug, but now you'll notice that the search space is much narrower. You don't have to look through as much code to find that bug. The last thing you worked on was that one sliver, that second column in the implementation box. So you know the bug is really really just in there, most likely. So you don't have to look through the entire program to fix a bunch of bugs all at once. You only have to look through and fix bugs in a smaller section of the program. So that will save you a lot of time and also just make it easier for you to actually handle debugging. So again, just spend the time now to outline your code, divide it up into sections, and then debugging will be easier later on. Because that's what really takes a lot of time, not just writing the initial code, but debugging it. And this, you can look at this later. Just show you, it's a link you can click on, and there's a whole page here. And there's this link here, 3 Virtues of a Great Programmer. Click on this as well. Hopefully it will load. Back. Okay. So, according to Larry Wall, author of Perl, there are 3 great virtues of a programmer. And you'll notice that each of these is actually a word with a negative connotation. So the first is laziness. The quality that makes you go to great effort to reduce overall energy expenditure. It makes you write labor-saving programs that other people will find useful and document what you wrote so you don't have to answer so many questions about it. So this should encourage you to write programs that are actually useful, actually automate some tasks for you instead of doing it manually. And then you write great documentation so you don't have to constantly answer questions about this program. You have great docs, you can just tell somebody, look at the docs and give them the link to the documentation. Impatience, so the anger you feel when the computer is being lazy. This makes you write programs that don't just react to your needs, but actually anticipate them, or at least pretend to. So good programs like, you may not have used the command line before, but if I go on the command line, oops, let me increase here. Type in CD and start to type in the name of a directory and press tab, it auto-completes. I would say that's an example of anticipating my needs. I don't have to type out a whole directory name, I can just press tab and it automatically completes to the directory that I'm typing in. And then hubris. So again, I like books, so I am familiar with this word. Hubris is in literature extreme arrogance against like divine beings, essentially, and you usually get smited for it. So it's a quality that makes you write and maintain programs that other people won't want to say bad things about. You're so proud of your own code, you wouldn't want to see anybody speak disparagingly about it. So you should feel a little bit of pride in your work, enough so that you don't want to see other people try and tear it down, or allow them the opportunity to insult it in any way. And I think that's it for these slides. Let's go over here. Oh yeah, differences from prior courses. So the only difference really this semester is going to be, I'm teaching the course, not Dr. Gazzillo. I might make changes to some of the assignments and slides and whatnot, but the main difference is that's going to be me you're listening to. And now we can go on to the syllabus. So any questions so far? I'm sure some people might have questions about what we went over. Yeah? So the PowerPoint and all the content of the course is on this website. And if you go to the first page here, Introduction, you will see an HTML rendering of all the content we just went over in those slides on this webpage. This is a way, again, laziness. I don't want to have to write, well, Dr. Gazzillo doesn't want to have to write separate versions and maintaining slides and web pages. So instead, we just have one source material that we export to different file formats, essentially. It's good for me because I don't have to prepare more, and it's good for you because that means you can just go to the website and review the same material that was in class, but without my richer explanations and ability to answer questions for you. Okay, so I guess no more questions. Okay, so course details. I'll zoom in here. This all I think is self-evident, where we are, the times. The TA is Donovan. He's a good guy. You'll meet him in labs when you go to labs. The final, it's already on UCF's website. So does everybody know where you can look up the final dates and times at UCF? You do? So in case you're unaware, there's this page every semester they generate this. You can just enter your class meeting times and it will tell you when the final is. Professors are supposed to follow this, so you can just always use this page. They generate a new one for every semester, so you can just use this. Our final is going to be on April 30th from 10 a.m. to 12 p.m. And I think it's going to be in this room. I haven't heard otherwise yet, so that's how you can plan accordingly. The labs, they're all going to be led by Donovan. They're all on Fridays. They will not be recorded, so it is in your best interest to attend them. It's going to be review for the projects and homeworks, and maybe some supplemental material at Donovan's discretion if he has time and if he has anything he wants to go over besides what we cover in class. Yeah?
Do we have to go to our assigned lab?
Ask Donovan, go to your assigned one the first day, and then ask him if he cares. He probably won't care. Yeah, I'm going to say you probably don't, but I would check with him because he's the one in charge of the labs.
Okay.
So.
Thanks.
And they'll be starting next week, so not this Friday. So don't go to labs this Friday. Similarly, office hours are starting next week, so don't come to office hours this week. I won't be there. I managed to secure this room, Health Science Building 244, so second floor of Health Science 2. And the times are going to be directly before and after class. I think that works with most people, hopefully. Yeah. And again, yeah, we won't have office hours, of course, when campus is closed. All the pages for the course, all the course content is here as well. So actually, let me actually just show you real quick the way to access this website in case you are wondering that. It's on the homepage for the web courses for this course. So if you just go to the course, web courses page for this course, and the link should appear right there for you to go to. So all these pages here are the future slides, future content for the course. They're all published right now, so you can review them if you want. I recommend just waiting. I mean, we're going to go over them in class anyway. There's, not much of a reason to get ahead too much unless you really want to, but it's better to, I think, go slowly and absorb the information that way. The homework assignments, projects, etc. here, they'll become available on the date listed in the left-hand column. So homework 2 is unavailable. It's not published yet, but homework 1 is out there, so you can start it. This is the academic engagement activity. All I'm asking you to do is to SSH into Eustace, one of the servers we have here at UCF, and take a screenshot. That's it. So it should be very simple. If you're not on campus, you'll have to use the VPN, the Cisco VPN, to log into UCF's network in order to access Eustace. But if you are on campus, like right now, you can go to a computer lab or use your own laptop and just SSH into Eustace and get the screenshot and submit it. Yeah, and there's an explanation at the bottom here of how this whole table works. But to summarize for you, the due dates are listed in the right-hand column. The publication dates for each project and assignment are listed in the column here. Homework assignments are due a week, I think it's a week after they're published. And for the grading, for the point breakdown, Dr. Gazzillo has this great idea of giving everything 1 percentage point. So you don't have to take out a nice spreadsheet or anything to calculate your grade. You can just count up the number of points you have in all assignments and you already have your grade. So homework's 20 points, exercises, these are more challenging assignments than homework projects, but not quite as challenging as actual projects. These are worth 4 points, 2 of them. The projects are worth 8 points, there's 6 of them. It's like almost half the course points, so take them seriously. And the projects, you can resubmit them after the deadline for only a 1 point late penalty throughout the semester. You won't be able to get a perfect score, but if you keep trying, because they are challenging, if you keep trying to correct your code and keep resubmitting them, you can get up to a near, like a 90 or well, 7 out of 8 at most. I think that's what's written here. Yeah. The midterm will be here, 8 points. Finals, 12 points, also will be here. The midterm should be listed on this table. Yeah, right here. So 3-3. And attendance is graded. So it's worth 4 points. So it's not going to kill your grade if you never come to class. But if you do come to class and your attendance is at least 75%, you receive, where is this here? Oh, right here. Yep. 2 bonus points. So if you can't make it because you're sick or something, tell me. I will not count that towards your total attendance count. But if you come to, at least 3/4 of class, you get bonus points. And I'll use UCF here to take attendance throughout this course. I'm not doing it today, but in later days, I'll be using UCF here. Has anybody used that before? Okay, cool. So you're familiar with it. For those of you who are unaware, it is essentially a sequence of randomly generated QR codes that you scan with your phone, and then that's how I can report attendance very quickly. All right, I was on homework. So actually, no. Homework is due the day before the following lecture. So not a week later. They're very easy, so you should have plenty of time to do it anyway. But before the next lecture, they're due. And they're not graded for 100% completion, or accuracy, I should say. Completion and generally the right idea. So just show that an attempt was made, that you took the assignment seriously, and tried to complete it, and you'll get full credit. And one more thing I want to mention is that the exercises and projects, they're all submitted via Git. So we have this service called Gitolite. It lets you essentially upload projects to our own sort of GitHub server remotely, and then we can grade them automatically. So the grading should be pretty quick. I have a grader that I've hired to run all the scripts to grade all your projects automatically. We're kind of, again, trying to show you how to use like real software engineering techniques, how to use Git to upload code. You're going to be uploading your code and get like not immediate feedback, but pretty quick feedback on how you've done on your assignments. So we're not using web courses for uploading projects or anything. It's all going to be Git from the command line. So midterm and final, you are allowed to take a copious amount of notes to these. So you get 8 double-sided pages of notes. So really, I don't see any reason why you want to cheat on them or anything. Like, you have so many notes, and if you attend class, they should not be overwhelmingly difficult. You should be fine. And we will be giving reviews before each exam. Yeah?
Why so many notes? Like, why? Is that an indication that it would be like hard or something?
If you just want a sense of security, I mean, it's not, I don't think it's hard, but I already know this material pretty well. So I can't really, I'm not really the person to answer whether or not it's hard. It's going to be fair. I will tell you that. It'll be very fair. It'll be off what we go over in the class. So, yeah.
Does it have to be handwritten or can it be like printed?
It can be printed. Yeah. Mm-hmm. Yeah, so projects, resubmit, up to final project resubmit deadline with 1 point deduction. This is the whole late policy. So no late homeworks. Exercises can be up to 2 lecture days late. Yeah?
Is the homework just like greater than 50% accuracy or not to work?
So if it's really just the right, like, the right calls to correct functions in the right order. That's really what I will say. I can't tell you, like, it's not like super specific. I don't have like a specific, rule book or anything. Just if you make the right function calls or right instructions or whatever in the correct order, you'll get full credit for the homework assignments. You'll see. They're not like super rigorous, I would say. The projects are the ones that are rigorous and very specific. So yeah, so there is letter grades. There's no A plus, no A minus, just A, but there are pluses for the other letter grades. Bless you. So Eustace, maybe I'll just demonstrate how that works. I mean, has anybody used Eustace before? Okay, so you all should know. So maybe I don't need to, I'll demonstrate it just in case anyway. Oops, so my password's wrong. And again, if you're not on the UCF network, you'll have to use the VPN to access this. I think it's taking a little while to load, so I'm just going to skip it. But that's the right idea. You just would say SSH, NID, eustace.eecs.ucf.edu. And we have instructions here as well. So computing requirements, you do need a computer. If you don't have a computer, there are computing labs on campus, and because everything we're doing is going to be really, well, the final destination for all the projects should be Eustace, and the other projects you can do, the homework assignments you can do from anywhere because you're uploading them to web courses. You should be able to do everything from a computing lab if you needed to, if you really can't afford a computer. Because you'll be logging into computers on campus if you want to, and then you can SSH into Eustace and then work on it there. And I really am going to encourage you all to use command line editors, which you can use from any kind of machine. So if you do learn how to use command line editors, you will be able to work from anywhere, essentially, anywhere that has internet connection and has access to SSH. Plus, Chromebooks and old laptops are very cheap and can run Linux very efficiently. And that would actually be really nice is you don't have to worry about using a virtual machine or anything. You can just install Linux directly on some cheap machine, and then you can just be working directly with Linux, which will be very nice. Make working with some of the things in this course a bit easier, I think. Yeah, use the VPN. There's some guides here. The Git server, I mentioned this. So we're going to be using this platform called EdStem for questions. So it's basically like an academic forum website. If you have a question, you just post it on EdStem. Everyone can see it. I prefer, once we get EdStem working, I'm going to get it set up next week. Once we get it working, I prefer, if you have a question, post it on EdStem. I'd rather you not email me, only because then I have to answer the question multiple times. If you ask me a question, it doesn't need to be private. Just post it on EdStem as a new forum, and then that way when I answer it, or one of the graders answers it, everyone can see the answer, and that question doesn't need to be answered again, or I can just link to that question if somebody asks the same question. And if you have a private question, you can either email it to me, or you can send it to me on EdStem via a private post, which I can't show you right now because you don't have access yet to EdStem, but there's a way to do that. UCF here. Now this is another important one, the textbooks. The textbooks in this course are totally free. You don't have to buy anything. We have access to them. They're online, but one catch here is that do not choose this option, the read online option, when you go to the web page for one of these textbooks. Let me see if this will work. So I can show you. Okay. So do not choose read online. Do not choose that. Choose the chapter that you need and click download PDF. The reason why not to choose read online is because we have technically one shared copy of the book. So if you choose read online, it locks everybody else out from accessing it. Whereas if you choose download, I guess each machine gets their own finite number of downloads. I'm not really sure how that works. But we have enough chapter downloads to where we can all download essentially all the chapters you need from each book, and we'll be fine. So choose download PDF and then browse the files locally. Do not choose the read online option because then you'll kick everybody else out. And there's a way to check who is the one reading online, so I can call you out. And yeah, you'll see, we're not going to read the entire books, just several parts of them. So you'll be able to download the chapters that we need and be fine. And I've read some of these chapters of these books. I want to read the whole books, but I haven't had time. And they are actually really cool. They're pretty like modern takes on C programming. And the Linux programming interface, this is going to be very helpful for accomplishing the projects in this semester. If you read these chapters, you should be able to do the projects without a problem. So again, recapitulation of the instructions. Do not click read online. And now there's also some recommended optional texts here, not necessary. But for your editor, so I want to give a bit of a poll. Raise your hand if you use VS Code. Okay. Raise your hand if you use Vim. Okay. Emacs? No? All right. NetBeans? Yeah? Okay, so a few people. So I'm not going to require that you use Vim or Emacs, but it does kind of fit with the course because we're learning how to use command line tools, and Vim and Emacs are command line tools, especially Vim. Emacs has a GUI, and so does Vim on some machines, but Vim is at its heart really a command line tool. And Emacs has great command line support as well. One reason not to use VS Code, and you can still use it locally, but the problem will be when you remotely log on to a machine using VS Code's SSH plugin, it creates a directory on that machine that takes up a lot of space and has a lot of bloat. And you will actually be unable to submit your projects to the remote server and upload them because the VS Code's like SSH directory that it creates will take up too much of your disk space that you have allocated to you on Eustace. So be aware of that. You can just write your code locally if you really want to use VS Code. Write your code locally using VS Code, test it locally in a virtual machine, and then push it once you're ready. Or you could just work on Eustace directly using Vim or Emacs. And I'm going to try and convince you to use one of these two editors this semester. So I use Vim. I use Vim a lot. I have like a Vim sticker on my water bottle over here. So I'm going to be like flying sometimes when I write code this semester. Hopefully to convince you that Vim is not a slow way to write code. And it's not archaic. Neither is Emacs. They're both very powerful tools that you can use. And really another good reason to learn how to use these tools that I won't bring up is that using Vim or Emacs encourages you to learn how all parts of the command line interact, because with Vim, for instance, you can read an input from a command directly into your editor. So it encourages you to kind of think of your editor as one tool in a sea of tools on the command line. But when you use a tool like VS Code or NetBeans or code blocks or something, it's sort of like a monolithic application that has everything inside of it. When you use VS Code, the terminal is inside VS Code. When you use Vim, Vim is inside the terminal. And so it encourages you, using Vim and Emacs, to think of the bigger picture of what programs are available to you to use. Whereas using VS Code gives you less translatable skills, I will say. It's still very effective. I used VS Code all throughout undergrad. I was a huge super fan of VS Code. And I got really fast. I could use control, arrow keys, shift. I knew all the shortcuts and whatnot. But now I use Vim and I don't think I'll go back. And so the first thing I'm going to recommend is to actually just check out Emacs or Vim. Go through the tutorials for one of these two programming environments, these editors, and just see if you like it. Give it a try. They're going to be dissimilar from what you've used before. If you like hotkeys, try Emacs. If you want to try something a bit different, a modal editor where you're changing modes and you can move around really fast in one mode and edit really fast in another, then try Vim. I like Vim, but Dr. Gazzola likes Emacs, and other people like Emacs as well. So, and again, I know some of you said you watched that YouTube channel, Primogen. He has a great series, I'll add a link here to it, on how to use Vim. So if you want to hear somebody like who's really animated and excited talking about how to use something and teaching you how to use it, I would recommend watching that. And so I'm going to go over some learning outcomes for the course. Actually, before I do, any questions before I continue? Okay. So basically, we're just going to go over a bunch of different system calls, re-implementing tools in the command line, learning how to use like git, make, how to use bash in the first half of the semester. And in the second half, we're going to be using this tool called Antler to write our own compiler. It's going to be in C++, but we're not going to use really any C++ features. If you programmed in Java before, you'll have enough knowledge of like how object-oriented programming works to implement this compiler. And as long as you know how to write C code, you'll be able to do it. So that's one of the fun parts. I mean, the whole course is fun, I think. This part's fun in a different way. It's really cool just to see like yourself build a whole compiler. I don't know. We're going to be targeting x86 assembly, so we're going to be writing this compiler to translate high-level source code into assembly code that you can run on your machine. And again, labs on Fridays, led by Donovan, once a week, not this week. So some policy statements. And one more statement that's actually not on here that I want to bring up, that I need to add to the syllabus on the webpage. I have to say, I kind of dislike the simple syllabus just because it's so slow. Yeah, so some people might think it's weird that we have like a separate website for the course, but I mean, look at this. It's like you reload it loads instantly. All the stuff's right here. There's benefits to having your own separate page. So at the bottom here, I have a statement on, and I have to say this. I wish I wouldn't have to. On AI use, I can't be like over your shoulder preventing you from using AI to help you with the projects or with the homeworks or with the exercises. But I will be over your shoulder for the exams, and I'll have my graders here too. So we will not allow you to use AI during the exams. That being said, again, I'm not there. I can't prevent you from using it to help you essentially cheat on homework assignments and exercises and projects. But I will say I strongly discourage it, and the reason why is because AI is a shortcut to accomplishing your goal that sacrifices your ability to, or forcing you to actually learn the techniques you would need to solve the goal on your own. So you're kind of taking the expedient route, doing what's quick rather than what's rewarding or fulfilling. Now, you can disagree with me, you don't have to listen to me on this, but I will tell you, every time I see an undergrad who uses AI, they are much less competent programmers than those who do not use AI, or those who rarely use AI. So please, just do not reach for chat immediately when you're trying to accomplish an assignment. Try to write the whole thing yourself first, and I can show you, I have done all these assignments myself without using any AI tools. So it is fully possible. And it's not like it's that, I don't know. It's going to be more challenging for you because you don't know the material, but it should be fun, like challenging in a fun way. So I strongly encourage you to avoid using AI for the assignments in this course. All right, and that's, I guess, about it. I'm sure there's some questions about what we've gone over, about the syllabus or anything. Yeah? Yep. Well, you might have to get used to using the command line then. No, the whole course, again, using command line tools, because these are the tools that kind of using behind the scenes in a lot of your high-level applications using behind the scenes. Yeah? I'm sorry. Wait. Is the file what? Oh, no, it's not cumulative. It is cumulative, but the focus is only being the second half of the course. So most of the questions will be on the second half. Yeah.
You said that the operators
Here's instructions. Yeah. And I will mention the permission file are here. They're going to be on your laptop using web courses. We're going to be just walking around graders myself to make sure you're not cheating or anything. But only digital. There's a paper option if you really don't want to use web a browser for your permission file. It's going to be yes, this is going to be good. UCF, I feel like it will help you. Yeah. You can also go to them in person in the AGC building, and Yeah, I know. I'll work with you. Send me an email with your number, please, and I will definitely accommodate you. All right, thank you. Have a good one, thank you.
I want to know like what qualifies as an excused absence because I will be working at an event and I have invested a lot of money in participating in said event and it is going
Okay.
to happen.
How far away is it?
It's here it's in the convention center.
Well, I mean, date-wise, sorry.
It's going to be Thursday, Friday. So Friday's not here, but I believe that's going to be either the 19th or the 20th of March.
Of this, March.
Yeah.
Um,
I
Well-
have to check and see whether it lands around the midterm or not, but
I mean, just send me an email. It's so far in advance. I'll excuse
Yeah.
it. It's fine.
yeah,
Because you
I
put
just
so much money
want to
into
know
it.
like because this happened last year during the spring semester, and I was like,
You can still, I mean,
like I will lose $600 if I don't attend.
you can go. Don't worry. Even if I were not to give you an exception, you still would
I
have
know,
over
I know.
75% attendance if you attend earlier
I
classes
know.
and still
I
get
just
the
want to know
points.
like
So,
what qualifies as an
Yeah.
excuse versus unexcused.
I will say things that I'm not excusing are if you have a full-time job and you just can't show up to class at all. I'm not going to excuse that. Like you should know about that before you
That's
sign
understandable.
for the course. So
But like this is like
yeah, right. That's fine. Don't worry about it. Just send me an email and I'll write a note.
Thanks, Professor. I am number 2 on the wait list right now for this class. And you said the assignments are due by the next lecture, right?
The homework assignments.
Homework.
Yeah.
So obviously that'd be Thursday for the first one, right? So if I'm not in the class by then, is that just lost points? I think I would be, but just in case.
Well, if you're showing up late because you just couldn't get in, because you couldn't be enrolled, I'm not going to penalize you for that.
Okay.
But that being said, it is the academic engagement activity. So I don't know what I don't really know what to do in that situation. If you're showing up late, if you're enrolled after the academic engagement period, I'm not really sure what the policy would be there.
Okay, but that's like the financial aid, you mean?
Yes.
Okay.
Yes. Academic engagement and financial aid is the same thing. Yeah.
Okay, so I assume I'll be in by then, but I was just making sure.
Yeah, send me an email and I'll write a note of this, and I'll find out who to ask to get clarity on how you can satisfy the engagement activity, even though you might be arriving after its deadline.
Okay, yeah, thank you.
Right, you're welcome.
I know you talked about research in the beginning. I was just wondering where I can find a link to like read
Oh.
about it.
So our website is just pathasprint.com.
That's really okay.
And you can click on this link here, and it will bring you to what I'm recently working on.
Yeah.
There's also this link here to some papers that I've written in the past with Dr. Gazzillo.
Okay, and do you have office hours where we can talk? Or
Yeah. Next week we have office hours.
Next
So you can just come to office hours, and if nobody else has questions, we can just talk about research and whatnot. I also have another project that I'm working on that I forgot to mention, a human factors project, where we're actually sitting people down and having them debug code in groups of 3 and studying their biometrics while they're doing that. That project has been underway for about like a year now, and I'm not sure if I need help, but I do need volunteers to participate in that project. So if you'd be interested in actually live coding, basically, while we have all these devices hooked up to you, that would be good for me.
yeah, I'm definitely interested. Where can I like sign up for that? Or...
I'm actually going to send out an email to the department.
Okay.
Send out to all the undergrads, so keep a lookout for that.
Okay.
And if you are interested in helping us with research,
Yeah.
I think I can add you to the newest project we're working on. You can sit in on one of our meetings. Again, send me an email. I'll write you
I'll send
down.
you an email.
I'll invite you to the Outlook event, and then you can come next Monday. We meet in BA 136C on Mondays at 2 p.m. Next week's gonna be different because it's a holiday.
Mondays at 2 p.m.
Yes, normally that's when we meet. Next week's gonna be Wednesday. I'll send you the details if you send me an email, and
Okay, yeah.
you
My
can
name is
come.
Razvan. I'll send you.
Okay, Razman.
Razvan.
All right. Well, please meet you.
Nice to meet you.
Hello.
First, you said you liked reading. What kind of books are you mostly into?
I like a lot of literature. So right now I'm reading Finnegan's Wake.
Okay.
Before that, I read some notable books that I read. Infinite Jest.
Oh my gosh, I almost picked that up last year, and then
Yeah.
I got intimidated. So
It took me a whole summer. It was worth it.
I feel like I have to like. I feel like I should get through House of Leaves before I.
Oh
even
yes, so
try
House of Leaves
to
is where you
touch
want to begin.
Infinite
With
Jest.
maximalist
I have House
literature.
of Leaves. I've had it for like a year. I have a million other books that I have to get
Yeah.
through first.
House of Leaves is good. It's ergothic literature in the sense that
Yeah.
the text changes.
Which is what I
matters within the
love.
story.
I live for that.
It's cool. I will say it's not as well written as like Gravity's Rainbow or Infinite Jest
You write that one
or
down.
Blood Meridian. These books are like masterpieces, I'd say.
Okay.
House of Leaves kind of rests on this ergodic literature thing,
Mhm.
which is cool, but the quality of it itself isn't
Alright.
the highest.
I mean, I'm in it for the gimmick, so
Yeah,
it's fine.
yeah, it's a gimmick.
Whatever.
But it still is well written, and it's a good introduction to that sort of like rich literature
Right.
that's like confusing and exciting. And if you really like House of Leaves, you might want to check out Pale Fire by Vladimir Nabokov.
Okay.
It's about a 999 line long poem, and the author died before he could finish the final line. But
Awesome.
half the book is a commentary on the poem. And the guy who
Oh.
writes the commentary, you learn more about him as you read the poem and then read his commentary. And he turns
That's
out to
really
be,
fun.
yeah, he's like this egotistical narcissist who might be the runaway king of
Love
some far off country.
Love it.
It's very weird, very much like
Awesome.
House of Leaves if you're interested in
Okay,
that.
cool.
Yeah.
Thanks. The second thing I had was, I know you were talking about Vim. Have you ever used NeoVim?
Yes, I use NeoVim.
Okay,
Sorry,
so
I use
would you
NeoVim.
recommend that over Vim? Because I know all my friends are always like, use NeoVim, use NeoVim. And I'm
For this
like,
course, use Vim first. There's no real reason. I mean, you can use NeoVim. There's not going to be much of a difference.
Okay.
Like, unless you're installing packages, there'll be a difference. But if you're just using plain Vim, which I recommend doing,
Mhm.
just use Vim at first.
Okay.
And then after the end of this course, go into NeoVim and start installing packages.
Okay.
Don't spend too much time configuring Vim because you're going to have to learn new configurations.
Right.
Yeah, commands.
Okay, cool.
Yeah.
That's all. Thank you.
All right. Yep. You're doing a good one. What's up?
I just have two questions. One, for the labs, I think I missed it. Did you say anything about whether they're required or not?
They're not going to be graded. I'd recommend going, especially if you want help with the projects and the homework assignments and the exercises. I would go to the labs because the TA, Donovan's going to be reviewing all that. And he has permission to go over the homework assignments. He has permission to go over big ideas of the exercises and big ideas of the projects. Not exact code, but he can give you code snippets and whatnot. And he can also give you some supplemental material that may not be covered in class. Also, Donovan's just a great guy, so I'd recommend going. Yeah. They're not going to be recorded either, so if you want to see them, you have to go.
Okay. And then also, I know there's 2 days for the class that I absolutely will not be here. But I don't know if this would count towards the.
Send me an email and I'll exclude you. I will discount it from the attendance policy.
Okay. But I don't know. It sounds like I'm gonna be like out of the country. Is
Mhm.
the main thing, not for like any of the things that are like the school requires to be. So would that
It's
also,
when is it going to be?
It's in February. I think the 10th and the 13th, or whatever dates in February. I think the second week.
Okay. Send me an email and I'll write down. I'll excuse you. I'm making a list of people who need absences. So just let me know 2 weeks in advance and I'll work with you.
Okay.
Yeah.
Thank you.
Welcome. Hello.
I know not many people did it, but I just wanted to introduce myself. My name is Jesse, and I really look forward to
Oh,
taking
well,
your
hello, Jesse. Thank you. I appreciate it. You too. Okay.
I wanted to ask you, right, about the projects. How would I expect it to be? Is it like an actual, like a project, like I had one for City A,
Mhm.
they went to me, and it was like, kind of building, I honestly don't remember what it was.
It was, I think, an interpreter for an assembly
Yes,
programming
yes.
language. Yeah, MIPS.
Something like that, or more like the average programming assignment. Like, I don't really know.
It's going to be more like that. So you're going to be given
Got it.
no code to start off with. It's all from scratch. You're going to have to write in C a program that will, for instance, let me see what the project's here so I can remember. So, for example, the FS project, you're going to have to write a find command. So I don't know if you've seen find before. If I go to, so you know, it finds files. Yeah. So you'll have to create a program that walks a directory tree and determines whether or not a file is present. That's one of the things that the FS project does or requires. And there's specific exit codes you have to satisfy in different conditions. So if this bug occurs, you have to exit with this code. If this bug occurs, exit with this code. If everything works, print out this output. And we have specific test cases for each one of those different exit codes and outputs.
Got it. Okay. Okay.
So it's all in C. You shouldn't need, really you should just need man pages. You shouldn't need anything external from man pages. The way we've structured the assignments, if you just read the man pages, you should be able to do all the assignments.
Got it. Okay. Oh, thank you.
Yeah, have a good one.
You said that we're uploading our projects to a Git?
Yeah, so you're going to be logging into, well, you don't have to log into Eustace, but I recommend logging into Eustace, doing the projects there, and then you'll be uploading your projects to this server we have secured. That's going to be on another server. Another one of UCF servers is hosting this, like, Gitto Lite is what it's called, service. You basically upload your projects there like any other GitHub server, and then we run some automated tests. The graders will run automated tests to grade your project.
Question, are we able to submit more than once for that, or is
Yes,
it once?
yes. So it's like GitHub. You can keep pushing changes. But changes you push after the deadline will only be counted with the 1 point deduction off the total.
And then another thing, you said that you're doing attendance based off like this UCF
UCF
QR
here,
code?
yeah.
Where would I find that?
It's going to be on the screen. I'm going to display it at the start of class, starting next class. And it's just going to be a series of randomly generated QR codes that will appear in sequence. And you just scan it with your phone, and then I can immediately see that you're attending class and what courses.
Oh, okay.
So,
Alright, thank you.
Alright.
Did anyone drop off any keys or something?
No, I do not see any keys here.
Thank you.
You're welcome.